Search is a very important technique, and if you do Google search or Facebook search or any kind of search algorithm, require you to write a program where it'll go through a list of things. So let's say that you have a list of things, and it'll go through this list and try to figure out something about this list. So you can search for a max element, min element, the second largest element, third largest element, and so on. So you can search for a lot of different things. You can search if the element exists or not, and so on. So now in this demo, what I like to do is to do something really interesting, to see if I can write a program to search for duplicates in an array. Now this array is not sorted, it's a random array. So if I'm looking for duplicates, then I need to come up with an algorithm where I can think through this array and figure out what it means to have duplicates. Now, there are many ways you can think about this, but you got to have your thoughts very well organized to figure out how to do a duplicate search. So now I'm going to suggest an algorithm which I hope you will understand, where I will run two indices. I will run an I index starting from I equals 0 all the way to the end of the array, and then I'll start a j index which will start from 1 after I plus 1 essentially, and run through the array until it reaches the end. So the goal here is that I will start, say for example, I equals 0. In that case, AI would be 0. AI would be 1. That's the element at the 0th element. Or A of 0 would be 1. And then J, I will start from 1 more than I. If I equals 0, I'm going to start from 1. Okay, J equals 1. So what I'm going to do is to run the J. I keep moving J while keeping I fixed for now at 0. So I'll keep running J until I see the same thing that I saw here. So in other words, I will look for A's of I in the rest of the array. So I go through the rest of the array and look for A's of I. So in this case, A's of I happens to be 1, since I fixed the I at 0. So I'm going to fix this 1 and go through the check. Here I found 1. Check. Once I find 1, I can return. So I don't need to do this again, because my question is that, does the array have duplicates? So I want an answer, either yes or no. So as soon as I find a duplicate, I'm going to be done. Now, if I fail to find a duplicate here, then I'm going to move the I by 1 and then start looking again, starting with the I plus 1. I'm going to look for the rest of the array. So now I need to put this into some Ruby code. We start developing this code now for finding duplicates in an array. Let me just start with this side here. I'm going to try to call this duplicates.ruby, and I'm going to write a function called has duplicates, and the only input I need to this function is a list. So this is going to go through and return true if it has duplicates. It will return false if it doesn't. So the way I'm going to think about this is the same way I discussed with you how I think about the finding duplicates. What I like to do is to fix A's of I, so I call this the outer loop, and then go through the rest of the array trying to see if I can find something like A's of I. So I'm going to look for A's of I equals A's of J. And if I don't find it the first round, then I'm going to go move my I to the next element and then do the same thing starting with I plus 1 here. So I will be able to then continue until about here, and that's as far as I want the I to go. So this would be the last index of I, and then the j would always go up to here, starting with the I plus 1. Okay, so how do we put this into code now? So let's take a look at this. So we're going to do the following. So we have two loops. One is that the I loop, which you call the outer loop, for I in 0 to list dot length minus 2. Why is length minus 2? Now remember that when we discussed this, I said I wants to go here. It doesn't want to go to length minus 1 because this would be the last thing, and then I'll compare that with the j here. So I'm only going to go to length minus 2. So that's the outer loop. And the inner loop, so which I will use j to control the inner loop. So inner loop will always start from I plus 1. So we can do I plus 1, 2, but the inner loop will go all the way up to length minus 1, 2. Now, the inner loops and outer loops work, so I'm going to put an end for this loop here, end for this loop here, and then I'll start filling in things. Now, the way the inner loops, the nested loop work is that it's going to fix the value of I, and then it's going to go through the entire loop here. So if you start from I equals 0, you're going to go j from 1 to length minus 1. If you get to the I equals 1, it's going to go, the j is going to go from 2 to length minus 1. Now, in each of those iterations, what I'm going to test is the following. If a of I is fixed in each iteration, if I can't find a of I equals a of j, in this case, actually, I am not going to call this a because I call this list in this here, okay? So I'm going to say if list of I equals list of j, then if it's the case, that means I found two indices, because I can never be equal to j, because since I'm starting j from I plus 1, the index I and index j cannot be the same. So what I will do is to return true if that's the case. Now, when do I return false? Well, when I get complete both loops and I did not find anything, then I should return false. This means that there are no duplicates in this array. So now what we're going to do is to test this idea to see if this is going to be a correct algorithm. So let me just go to the Ruby and load the file called duplicates, and it seems to have some sort of an error here, which is kind of good in some ways, because it's an error in the line number 9. So let's just go here and see what the problem with the line number 9 is. In fact, it turned out that the end goes with this 4, and this end goes with this one, and this end goes with the function, but it turns out that I have not put an end here to complete the end for the if statement. So it's a good thing that we saw an example of how things can go wrong. So let me try to do that again. Now this time it turned out to be good. So now let me try to test this function. So let's have an array that has no duplicates. So I should get false. So I'm going to say has duplicates, and the array is A. So if I did this correctly, I should get false. So what if the array has duplicates? Let's try that. Now it gives me true. What if the array is empty? So here's an empty array. So I'm going to look for duplicates in an empty array. That cannot be any. Gives me false. Now I can try more things. I can give an array that has all duplicates and then look for duplicates. That's true. And I can look for an array that seems to be different until you get to the last two elements. And does that have duplicates? It's true. So this shows that the algorithm that we wrote here seems to stand the test that we are conducting. So the logic is fairly simple. You have two loops, out loop, inner loop, and a condition where that tests whether list of I equals list of j.